Hello, everyone. Welcome to Infor OBE Global Summit 2022. I am Dr. Mashur Rahman from United International University, Bangladesh, and I am moderator of this PMS parallel session titled AI and Machine Learning under the theme of transformational education using technology, challenges and benefits. We got two speakers in this session. Each speaker will get 15 minutes of time for presentation and 5 minutes for question and answer. We'll try to make this timing. Without further delay, I'd like to invite our first speaker to share his presentation. The title is Artificial Intelligence in Medical Education. Are there more questions than answers? Given by Dr. Prashant Gowda, Associate Professor, Department of Pediatrics, National University of Science and Technology, Muscat, Oman.
Thank you, Dr. Rahman, for that kind introduction. At the outset, I would like to thank the organizers of this event for giving me this opportunity to share my experience with artificial intelligence in medical education. So I am from National University of Science and Technology, Muscat, Oman. So the presentation today has the following contents. Before that, I would like to have a disclaimer that the presentation is going to be not as technical as probably is expected, considering the type of audience we have today. So I'll be covering the basic principles or the understanding of artificial intelligence along with its application in education, then application in medical education, and some of the questions which are unanswered. And I'll also consider some of the future prospects we have with relation to AI in medical education. And I take this opportunity to present my project, which I'm undertaking under FAMER Fellowship, which is considering the AI-based skills to teaching students. So let's begin the discussion. So before we talk of AI, I think we should know about these two great men. If the audience are aware of the names of these great men, they can please type in the chat box. I'll give some time for them. On the left-hand top corner, you can see a British mathematician and computer scientist who was actually the first person to have the idea of having thinking machines. So on the right lower corner, we have the person who coined the term artificial intelligence, and he's also a computer scientist. So Alan Turing is the one I was talking about earlier, and John McCarthy is the one who coined the term artificial intelligence and is often considered the father of artificial intelligence. So Alan Turing is known for Turing test and Turing machine, which are still being considered as one of the early machines or the ideas which proposed use of computers to sort of think of intelligence. So before we proceed, I have a quick overview of the terminologies because the audience generally tend to have kind of unclear definitions because there are no universally accepted definitions for these terms. Artificial intelligence is a broader term under which we have machine learning, which is a subset under AI, and deep learning is a subcategory under machine learning. And you can see that artificial intelligence mainly is about simulating the human intelligence, which tends to perceive the environment and tends to have the reasoning capacity along with the problem solving techniques. So machine learning basically is about mainly algorithms, and it's about pattern recognition and decision trees. These are some of the examples I have given. There are much more to this than what is mentioned here. I'll cover a little bit about that in the coming slide. And about deep learning, we have virtual assistants and chatbots as examples. We do have facial recognition algorithms, which actually so coming to the AI itself, as you can see here, AI is a broader term, and we have machine learning, neural networks, and deep learning. So neural network is nothing but layered algorithm, which is inspired by human brain. So human brain has a lot of neurons which are interconnected, and neural network is a kind of simulation of the same using algorithms. So the AI definition, I'll be very quick about this because we have other things to cover today. So it's a computer-based technology that could mimic human intelligence, and that is used to predict, automate, and optimize tasks that humans have historically done. So that examples include speech recognition, facial recognition, and so on. So, and there are subtypes of AI, which is for general understanding. So artificial narrow intelligence, which is considered as a mild type of AI, and artificial general intelligence is slightly superior to that, and we have artificial super intelligence, which is the best form of AI, the strongest form of AI, so to say. So coming to the applications of AI in education, so we have multiple ways we can apply AI in education in general. Before we go to medical education, so curriculum and outcome reviews can be conducted using AI. Artificial neural networks have the ability to solve multiple problems. They can classify more accurately, and they can generate a relationship between the variables in a much better fashion compared to other regular statistical methods we have. And we have student learning monitoring also, which is useful when you have AI application, and can be done more efficiently, more objectively, and all. And it has student feedback, which is a very important aspect of AI application education, apart from assessments. So generally, well-known applications of AI include grading, which is nothing but assessments, admin tasks, voice assistants to help students, to guide students, and we have smart content and personalized learning. So these are some of the applications which are very popular to be used in education. Coming to, before we go to the medical education and AI, so I must talk about learning analytics, which has evolved considerably over the last decade. And it is about like how we can assess what is happening with the students, giving the prescriptive nature of the educational environment, and descriptive aspects such as what happened and why did it happen, and what will happen. So all these types of analytics are evolved considerably over the last decade, and thereby they have influenced the AI in education in terms of pedagogical contexts and assessment regimes. And at a larger context, so studies have examined that how insights derived from big data analytics on pedagogical patterns could be used to generate or inform instructional designs at a micro level. So learning analytics also help the students to assess their own competencies, like in the form of tutoring and getting feedback. So coming to the medical education itself, so we have pre-existing frameworks which have been already implemented over the period of several decades now. So that include intelligence computer assisted instructions. Intelligent tutoring system is a very well-known entity. For the sake of time, I'll not be able to go through all of them. Just I mentioned the names here. Adaptive learning environment and then intelligent learning environment are the ones which are already being tested and executed. We have in medical education. And there are many more things in healthcare setup, which I'll not be discussing today. Again, for the sake of time, I'll be focusing mainly on medical education and AI. So some of the examples where AI has been successfully used in medical education include these topics or the projects. Again, there are many more to the list, to be added to the list. But for the sake of time, I will not be going through those things. But I'll take two examples here. One is cardiac tutor, which is used to train students in advanced cardiac life support. And it is based on intelligent simulation tutoring. And here is the interface. How does it look like? You can see the interface here. And it is basically drives the simulation into appropriate problem state, and students are trained according to their individual needs. So that's a beauty of AI we have. So in a class of, for example, 100 or 120 students, it is highly difficult for a teacher to give individualized feedback to many students accurately and more objectively, but AI can do it. So similarly, we have other project which is called Safari project, which was mainly implemented in surgical ICUs. And it is a simulation-based intelligent learning environment, which I mentioned earlier. So it's based on cognitive task analysis of the domain where it is conducted over those areas, and it is used to design the surgical ICU computer learning environment. So it's a type of intelligent learning environment which was successfully implemented. And I should also talk about most recently published study from Taiwan, where they try to use AI-based system for training and assessing interns in the skill of suturing, or surgical suturing or ligature skills. And this is how they did it. You can see the mannequin, which has got sensors and which are giving input to the AI-based system in the laptop. And the results will be, the students' technique will be analyzed, and the feedback will be given in an individualized manner. And the study had comparison groups. They had three groups. One is a regular group. The second group, you can see in the highlighted text, expert-led tutoring, where the experts are tutoring the students standalone. And the third group had experts along with AI tutoring group, which is shown in the previous picture. So they had 3 hours expert-led tutoring, followed by 1.5 hours of AI-based assessment and training. So followed by that, these are the results, which are quite interesting. So try to consider the highlighted box here. We can see the expert-led tutoring group had got a global rating of 4, whereas the expert-led plus AI tutoring group got a global rating of 4.5, which is statistically significant. And you can also see that the performance was much better when the students were trained using AI-based tutoring system, which is 90% of them were compared to 79% who are not used AI-based tutoring system. So this study actually published recently, it's an important highlight, where AI-based technology can be used to train students in clinical skills as well. So this is a promising study. And when I'm mentioning the highlights, I should also mention the failures. But this is not a failure which is seen in medical education. The failure is here about healthcare related AI application. The best known project of IBM, which is Watson for Oncology, was actually developed in 2013. And when it was implemented in Korea and US and some other countries, it was later realized that the data was not, the output was not accurate as expected. And the reason being, they thought that the input given to the AI system, it's not a failure of AI system as such. It is a failure mainly due to the lack of integrity or credibility of the input data. So there were hypothetical cases were used for input data, and it was mainly single center data. So that these are the reasons why they thought the system failed, and it was not implemented in a big way as planned, and huge amount of money was involved, and the project was finally dropped and it is no longer used. There are efforts to revive it, but it's not successful as of now. So this is one of the notable failures of AI, but again, as I said, it is not related to medical education as such. So coming to the next part of the discussion, which is questions unanswered, which I just discussed a slide before. So there are some failures, but mainly because of misunderstanding of the concept itself. And there is something called explainability. So explainability is something, the decision is explained on the basis of something. So if the AI-based technology is used, it is difficult to explain it because the technology is so complex. It uses multiple algorithms, and it is difficult to explain the decisions taken by the AI-based system, and that will actually make people question about the output itself. So again, it is difficult to assess the effectiveness, in the sense the question is still not answered. And external validity, as I mentioned in the previous slide. So if you are taking data from a limited number of students or limited number of health centers, the external validity is often questioned, and unless you apply and test the same system in some other environment, it is difficult to assess the external validity. And as I mentioned, quality of the data, which is input data, which is very quintessential to get the more accurate output. And quality of the feedback also is something we often question, because there is no human touch here. So there is no human factor involved here. And of course, a lot has been written about ethical issues of AI, using AI, questioning the development of physician skills and relationship with the patient and so on. So for the sake of time, I'll be very quick here. There are many more questions which are being asked by reviewers based on the available literature. So one important aspect which I would like to highlight is, like, rather than thinking about the method or the AI technique which is used, so we need to think of, will the next generation of medical student remain the same as of now? So if you consider the advancement of technology, so the nature of students who are coming into medicine, it becomes probably not predictable that way. So use of technology itself is, I think, is a good way to counter that. So use of technology will make us better prepared for training future doctors. So there are many more reviews which are related to student perceptions, the younger generation perceptions, and the results are promising, I would say. And experts are expecting that the machine learning or AI-based technology will bring in the next paradigm shift in the medical education. And we have future prospects coming from different agencies like American College of Radiology. They have listed FDA approved medical machine learning algorithms, which are about 48. And you can see that more and more number of studies are being conducted which employ machine learning on AI-based technology. Almost more than 1,200 studies are being conducted now, which are registered under clinical trials. And many institutions in the US have taken the lead and initiated several projects in AI use in medical education. And you can refer to this list later on because of the, in the interest of time. So the general prospects look promising, I would say, considering that digitalization is taking place at a very rapid pace, and there are improved interfaces, and the bandwidth is improving, and visual representations are improving. And there are new models coming up which mainly focus on student learning and learning analytics, as I mentioned earlier. So again, there are many scope, like a lot of scope for actually use of AI in clinical training, like for example, virtual operative assistant, which will train the resident in doing surgical skills. The Taiwanese study which I mentioned earlier is basically about surgical skill itself. And it has been recommended that AI can be implemented at different stages in medical education, starting from medical entrance exams or eligibility test, preclinical, clinical, and then during residency, and even specialists can be trained, because we have a lot of AI-based applications in healthcare now. And of course, as medical educators, we should be prepared for implementing AI ourselves, right? So these are the framework which are used by ACGME. So to train students in different aspects of medical practice, I would say that all these 6 areas have the potential to get AI into the curriculum, and that will help the students. So because of shortage of time, I will not go into the details of the project. So I'm currently conducting a project under FAMER, International FAMER Institution, which is mainly dealing with AI use to train medical students in diagnostic reasoning. And so we are planning to use natural language processing component to help the students learn diagnostic reasoning. And we'll prepare virtual cases by providing the machine with clinical data, which include diagnostic factors which the student need to pick up. And the machine actually will give the answer to the student, so that it will guide the student to reach to a diagnosis. And once the student reaches the diagnosis, right or the wrong, the immediate feedback will be given, which is highly individualized based on the student's efforts to select the diagnostic factor as well as build the hypothesis. So That will give a individualized feedback as well as keep a watch on student performance. So we have two phases of implementing. One is to train the faculty and student. The second phase, we have students are being given these sessions where they use the AI-based tool to practice diagnostic reasoning. And we, of course, get feedback from students and faculty. So subsequently, this is how the future system is going to look like. This has been derived from one of the prototypes already published previously. So this is too complex to go through, but the left-hand side has the data gathering processes, and the right-hand side has data analysis processes. And actually, basically, we are giving the input scenarios to the system and including physical examination, medical test, and then
Dr. Prashant,
yes.
I think you can take few more minutes because our next speaker is not uh, here yet. So
Sure.
please feel free to take more time. No problem. Yeah.
Thank you, Dr. Rahman. Thank you very much for that input. So we have data gathering and data analysis part, and the student does data gathering through the input scenario, and the questions are typed or asked in English language. So the machine will have an algorithm which will analyze the speech of the student and the factor which is given as input, and it also provides the physical examination finding if requested, as requested by the student. If the student is on the right path of reaching a diagnosis, so the machine will lead him towards wherever he's going, and he will also keep a track on how the student is asking questions, what points he is looking for. So is he on the right path? Is it taking a lot of time to reach the diagnosis? So all such aspects of student learning are being monitored and recorded by the computer-based interface. So then student gets into binary analysis and then pattern analysis, which is being taught to him by us as faculty. And based on that, he has to select the diagnosis, which is provided, different options are provided by the AI-based algorithm. So this is how, in a nutshell, like how the system is working, and I can give you more details of that. So this is how it is looking like. On the left-hand side, you can see the different roles. For example, students are and then the case creators are the faculty, admins, and we have content manager who are mainly from the IT background. So they are actually running parallelly. One is the web server, which is for the admin. The top one is the web server, which is for the student. So this is simulation mode. We have two modes here. So one, we can monitor also and edit and make changes as needed, but a student can only view it. And that's a presentation mode in the middle, which is in the green. And actually, as a student is given different diagnostic factors, he need to select those and reach to a diagnosis. And the algorithm actually creates a model for the student, individual student. It's called student model. And then it uses NLP model, which is highlighted in blue. So through that model, actually, up-to-date database related points are taken into consideration. And by the cases we are providing to the student in the system, the algorithm will be created and the student will be able to use this algorithm. So on one hand, this machine learning algorithm actually develops itself. That's where the artificial intelligence part comes into play, as well as it will keep a track on student performance. So that the student can be given an individual feedback. So, and we are trying to use IBM Cloud Server for managing all the cloud object storages and related software components. So up-to-date database, we have subscription already in our institution. We'll be using that also, so that we can have the student can have a rich experience of different medical conditions, because they generally come across some of the very common medical conditions, and we need to cover all those conditions. So this is the outline, and this is the skeleton, inner skeleton. You can see two types of colors here. One is dark gray. So dark gray boxes are the algorithms, which is kind of technical for you to understand. This is the skeleton of our system which you're planning to have. So whereas the light gray boxes are the data sources. So here our duty is to provide the AI-based interface, the inputs, which are light gray cylinders. You can see the data sets are provided, and medical books and corpus, basically the knowledge, which is including up to date I mentioned. So that kind of inputs are provided to us. Input questions will be provided by the student, and based on these algorithms, the machine will match the answers to the questions answered by the student, asked by the student, based on the input given by the faculty. So it may seem complex, but it is actually very simple. So I try to explain it, and maybe you need more time in case you're not understood clearly. So that's a overview of what the project is about, and we are going to evaluate the project and by assessing students. So once a student undergoes all these kind of training exercises, and by the way, he or she can use the AI-based algorithm at his own will and wish. So whatever is the number of time he wants to do it, he can do it, which is again an advantage, unless clinicians often have limited amount of time to spend with students. So the student has access to AI-based algorithms or the interface. Basically, he can use the training material whenever he finds the time is useful, like in a sense time is available for him, he can use and practice. So that's another advantage. So once it is done over a period of I think we are planning to have 3 to 4 weeks of training, we'll have an assessment for the student, which we call 20 minutes diagnostic reasoning test, which will customize for our institution. And it will be a classroom-based face-to-face oral assessment. We come out of the system now and see that in real life, how the student performs when it comes to diagnostic reasoning. So such assessments actually make it more practicable, and kind of they validate the training which is provided through AI-based interface. So followed by that assessment, we mark the student and look at his performance. And we also get some interviews of the students to get the feedback about their experience, so that we can modify it further and improve on that further. So this is a part of evaluation, and with that, I think we come to the end of the presentation. So some of the take-home messages I would like to give are, in the future, complex problem solving has been identified as a key skill for healthcare workers and even in other areas. And medical students are our future doctors, and they should be able to perform complex problem solving activities or exercises. And we know that in the coming days, AI is being used or being implemented in a big way possibly, and students should be prepared for that kind of a experience. So that is one message. And we have any potential application of AI in medical education should consider the outcome. So the outcome remains that having competent and safe doctors. So that factor cannot be overruled at any stage. So whether you use AI or we do not use AI, the ultimate or the final outcome which we are looking for is having competent and safe doctors to serve the community. So that's an important message we should never forget. And we have ability to provide individualized student learning through AI, and we can monitor the performance of students, also give feedback. This is one of the greatest features of AI used in medical education. So there is a need to increase AI adoption in medical curriculum by addressing the technical difficulties using innovation. So as I mentioned, there could be a possibility of a failure, but that should not hinder us from conducting a few more innovations so that we overcome the drawbacks. Those are the questions. Are there more questions? I would not say no. There are some questions, but there are more answers than questions to the topic here. So what is the role of AI in medical education?